Okay, so I want to do a quick, a really quick lesson on exponent rules that we would normally learn in chapter 7, but I will come back to more of these. We're just going to do the basics. Okay, so what I want to talk about is what's the difference between x plus x and x times x. Okay, so we know that x plus x, there's a 1 right here and a 1 right here, and it's just 2x when we combine like terms. Okay, but there's a difference when we multiply. Okay, so what we do when we multiply is we have to know that there's actually a 1 exponent right there and a 1 exponent right there. So yes, there was a 1 exponent right there and a 1 exponent right there. But when we combine like terms, we don't change exponents. You guys already know that. When we do 3x plus 4x, that's just 7x. We don't change exponents. Okay, when we multiply, we do change exponents. So what we're going to do is we're going to add the 1 and the 1, and we get x squared. Okay, so let's do something like x squared times x to the 4th. Okay, so we're multiplying right here, but the rule is when we multiply, we add exponents. So we actually get x to the 6th right here. And the reason being is because the exponent tells us how many x's there are. That would be 2 of them times 4 of them. Okay, so this is 2 of them, this is 4 of them. Exponent tells me to write that many out. When you go through and add these all up, there's 6. So it would be x to the 6th. Okay, let's do x to the 10th times x to the 15th. Okay, so what would the final answer be? That would be x to the 25th. You could write out 10 of them and write out 15 of them if you wanted to. Now, the other thing that you need to realize is that there is a coefficient of 1 and 1, but the operation does not say add. The operation over here says 1 times 1, which would be a 1. Means we don't have to write it. There'd be a 1 right here and a 1 right here, so 1 times 1 would be 1, and again, we don't have to write it. Okay, but what would you do if it was 3x times 4x? Okay, so yes, we are going to take our x's and we're going to add those exponents, so we get x squared. But what do you suppose we do with the 3 and the 4 now, rather than add them? We multiply them. So 3 times 4 is 12, and that's exactly what it says, 3 times 4. So you get 12. Okay, so let's do some examples down here. All right, ready? So example number 1. The 2 gets multiplied by the 5. 2 times 5 is 10. I know I have an n, and 4 plus 4 is 8. So my final answer is 10n to the 8th power. Okay, this is multiplication, so I know what to do with the 6 and the 5. 6 times 5 is 30. I multiply those two. Invisible math right here. R has a first power. So R the first and R the second, combine those, that would make R to the 3rd. Okay, hopefully you don't have any questions, but let's keep rolling. 2 gets multiplied by 6. It says multiplication. And then n and n, these two get added. N to the 8th. Okay, put your invisible math right here. Put your invisible math right there. 6 gets multiplied by 1. 6 times 1 is 6. K to the how many? Add those up. 3rd power. Okay, now when in doubt, you could write it out. You could do 6 times k, because there's k squared, times 1 times k, and then you could do this all out. 6 times 1 is 6. 1, 2, 3 is k to the 3rd. So if you need to, you could write it all out. You don't have to, though. I think this is easier than that. So what do we do with the 5 and the 8? We multiply. What do we do with the b squared and the b to the 1st? We add exponents. B to the 3rd. Okay. What do we do with the 4 and the 3? We multiply. What do we do with the 2 and the 1? We add exponents. Okay, so let's zip through these a little bit faster. 6 times 2 is 12, x to the 1st and x squared, x to the 3rd. Okay, put a 1 right there. 6 times 6, 36, 1 and 3, x to the 4th. Okay, so let's turn the paper over, pause it if you need to. What do we do if there's different variables? Okay, not a big deal at all. We take our 7 times 10 times 8, take all three and multiply them out. So 7 times 10 is 70, 70 times 8 is 560. Okay, now take your U's and your V's and do them alphabetically. U to the third and U to the first would be U to the fourth. We add the like exponents. Now we have to do our V's separately. So how many V exponents are there? 3 and 5 make 8, plus 3 more would make 11. So all I did was I alphabetized, so I did U's first, and then I did V's. I combined U's exponents, I combined V's exponents. But don't forget, the 7, the 10, and the 8, we still just multiply out front. Okay? So 9 gets multiplied by 9, which is 81. I have x's and I have y's. So let's do those separately. X to the first, x to the fifth, that would be x to the sixth, y squared and y squared makes y to the fourth. Okay? Hopefully you're feeling okay with this. So 6 gets multiplied by 8, 48. I have m to the third and m squared. 3 plus 2 is 5. And my n to the third and n to the third, 3 plus 3 is 6. Okay? Cool. We're just filing and organizing and learning an exponent rule. Just remember, though, when we're adding these exponents, that doesn't mean we add 6 and 6. 6 and 6 are out front. So 6 times 6 is 36. Okay? I'm totally done. Important thing to remember on that one. All right.